Hey everyone, welcome. Today we're diving into something that is happening literally all around you, every single second of the day, even inside you right now. We're going to pull back the curtain on the invisible forces that remake our world, chemical reactions. I mean, just think about it for a second. Ever notice an old iron fence getting that reddish, fleeky rust on it? Or watched a piece of wood in a campfire turn into nothing but glowing ash? Heck, even the lunch you ate is going through a wild transformation inside your stomach. So, what's the deal? How does all that happen? Well, it's not magic, it's chemistry. Every single one of those things, the rusting, the burning, cooking dinner, even just breathing, it's all powered by chemical reactions. They're the engines of change in the universe. Okay, so let's get down to it. What is a chemical reaction, really? Let's lock in a clear definition before we go any further. The most important part of that sentence is new substances with new properties. You're not just mixing stuff, you're creating something brand new. A classic example, you take hydrogen gas and oxygen gas. On their own, they're both invisible and super flammable. But let them react, bam, you get water, a liquid that you can drink and that puts fires out. It's a total, complete transformation. And this stuff is happening everywhere, not just in a lab. You see it when a car door rusts, when you light the grill for a barbecue, every time you eat a meal, and with every single breath you take. These are all chemical reactions just playing out in our daily lives. All right, now in every single reaction, you've got two main players. I like to think of it like baking a cake. You have your ingredients that you start with, right? And then you have the finished cake that you pull out of the oven. Well, in chemistry, we call those reactants and products. So your reactants are your starting lineup. They're the ingredients that are about to get mixed together and changed. When you look at a chemical equation, you will always find the reactants on the left side of the arrow. And the products, well, that's your finished dish, the grand finale. They are the totally new things that get created during the reaction, and you'll always find them on the right side of the arrow. Simple as that. This table just sums it all up perfectly. On the left, reactants, the stuff you start with. On the right, products, the new stuff you end up with. In our example here, magnesium and oxygen are the reactants. They combine, and the product they form is magnesium oxide. Reactants go in, products come out. Okay, so we've met the players, reactants, and products. But what kind of game are they playing? Turns out, not all reactions are alike. So to make sense of it all, chemists have sorted them into different types. Knowing these types helps us understand what's going on. We're about to walk through 8 of the most common ones. So here's our little roadmap for the next few minutes. Let's get right into it. First up, we have the combination reaction. And honestly, the name says it all. This is where 2 or more simple things combine to form one single, more complex thing. The general idea is A plus B comes together to make AB. A perfect real-world example is burning coal. Carbon from the coal combines with oxygen from the air to make one product, carbon dioxide. Next, we've got the total opposite, the decomposition reaction. This is where one big, complex thing breaks apart, or decomposes, into several smaller, simpler things. Think about heating limestone. The one reactant, calcium carbonate, breaks down into 2 separate products, calcium oxide and carbon dioxide. One thing becomes many. All right, now for a little bit of drama with the displacement reaction. Think of this like a more aggressive element showing up and kicking a less aggressive element out of its spot. In this example, iron is more reactive than copper, so it comes along, boots copper out of the copper sulfate, and takes its place. Poor copper is left all by itself. So if one swap wasn't exciting enough for you, how about a double displacement? This is basically like 2 dancing couples deciding to swap partners at the same time. The positive part of the first compound pairs up with the negative part of the second, and vice versa. And boom, you get 2 totally new compounds. This one is really cool because you can actually see it happen. In a precipitation reaction, you usually mix 2 clear liquids, and suddenly a solid material forms out of thin air and starts to settle at the bottom. That solid is called a precipitate, and it's a dead giveaway that this type of reaction just took place. Okay, let's talk about energy. An exothermic reaction is one that releases energy. It gives off heat. An easy way to remember it, exo sounds like exit, so heat is exiting the reaction. It makes its surroundings feel warmer. That campfire we mentioned, totally exothermic. The process your body uses to get energy from food, also exothermic. It's what keeps you warm. And the opposite of that is an endothermic reaction. So if exo is exit, endo is like enter. These reactions have to pull in energy from their surroundings to work, which actually makes the area around them feel colder. The number one example of this is photosynthesis. Plants have to absorb energy from sunlight to make their food. And last but not least, we have redox reactions. Now, this sounds pretty technical, but the main idea is actually simple. It's all about trading electrons. One substance loses electrons. We call that oxidation. And another substance has to gain those electrons. We call that reduction. The most important thing to remember is that they're a team. You can't have one without the other. They always happen together. Woo, okay, that was a lot, I know, but we covered the essentials. So, are you ready for a super quick quiz to see what you remember? Let's do a little knowledge check. Okay, first question for you. Think back to that recipe analogy. What do we call the ingredients? The stuff on the left side of the arrow that you start with. If you said reactants, you are absolutely correct. Nice work. They're the substances that are about to react. All right, last one. Take a good look at this equation. You've got two different things on the left, and they're forming just one single thing on the right. Which of our 8 types does that sound like? And the answer is a combination reaction. Two things are combining to form one. Perfect. You're getting the hang of this. So, what have we learned? That chemistry isn't just something in a textbook or a lab. It's the story of our world. It's happening when you cook an egg, when a battery powers your phone, when leaves change color in the fall. So as you go about the rest of your day, keep your eyes open. What chemical reactions will you spot now that you know what to look for?